Well, yeah, basically that. So yeah, so a fuse, um, it as a symbol, it looks just like a when you draw draw the symbol. It looks just like a resistor, but the wire goes all the way through it. I'll get a picture of one as well. So this is the symbol for it, and as you can see why the one on the left, you got the thin wire going through it, and the one on the right is actually how they normally look, where it would say the value of that fuse, 3 amp in that case. So why is a 3 amp fuse called a 3 amp fuse? So it's called a 3 amp fuse because if a current of over 3 amps went through that fuse, it would blow. We say blow, it basically means the metal inside of it would melt. So, and as you said, the reason for it doing that is because we may want it to break the circuit. So let's try to imagine why would we want it to break a circuit? Well, if we've got a light bulb, well, I mean, let's imagine it's something a bit. Well, we're just going to say it's a light bulb for now, and we've got some sort of power supply, and essentially the normal working current, whenever the current goes around this, whether it's AC or DC, but just draw it as if it's DC at the moment. Then maybe the normal working current that went through this, if we know that the voltage is, let's say we know the voltage is 100 volts. Maybe for whatever reason, the current, whenever we get a voltage of 100 volts, the current is going to be, say, 10 amps, right? So now, if something went wrong and a bit of this wire frayed off and touched and took a shortcut, what would happen to the current then? Yeah, so the current would more likely, the vast majority of it would go through this wire over here. So it's maybe a tiny amount might go through the light bulb, but most of it's going to go through this wire because it's a lot easier to go through. It's got much lower resistance, hasn't it? The resistance of the light bulb is going to be a lot greater than the resistance of this wire here. So what would happen to this current? Let's say if I had an ammeter reading, originally it read 10 amps, would the current now be higher or lower or the same? So now it's allowed to go around the circuit a lot more quickly, a lot more easily than the current is going to shoot up. It's going to go really, really high. So basically, generally speaking, when the current shoots up, it's because something's gone wrong. We would call this a short circuit. You've probably heard the phrase short circuit before. It's taken a shortcut. And so we would want something to go in there to measure whenever the current shoots up above a particular amount, the normal working current, then I want you to cut the circuit. So that's what a fuse does. So that's why we have fuses. And you can see in this case, a 3 amp fuse wouldn't be much good because if everything was going fine, it would blow anyway. So we would need a different fuse. We'd probably want to use a 13 amp fuse for this situation. There are a few different fuses to pick from. I'm not sure whether or not you need to memorize them, but and in any case, well, okay. So basically, there's the most common ones, I guess, are 3 amps, 5 amps, and 13 amps. Although there are other ones, of course. There's a 1 amp fuse you can buy. You can imagine you could buy a fuse of any value at all just by changing the thickness of this wire or the what it's made out of. I suppose it's probably just the thickness though. 1, 3, 5, and 13 amps. I think you can also get a 10 amp fuse as well. It's fairly common. So anyway, so I wouldn't choose a 10 amp fuse because if it just went a tiny bit above 10 amps, I wouldn't even choose 11 amp fuse because in case it fluctuates a little bit. But if it went to 13 amps, we can be fairly confident something's gone wrong, and so we would like it to break the circuit. Okay. Now they've upgraded fuse because the downside to these fuses is that once it's blown, that's it. You need to buy a new one. So most plugs come with regular fuses, but houses don't come with fuses anymore. They come with circuit breakers. So gone are the days where if a fuse blows, you don't need in your house, you don't need to go to the shops and get a new one. You just flip the switch. We won't go into how circuit breakers work here. We're just going to focus on fuses and essentially how to pick the right fuse. So let's say that we know, in earlier lesson we looked at the voltage was equal to, for mains electricity, is 230 volts, right? We also said the frequency for mains electricity is 50 hertz. Both of these numbers they would like you to know. But we're just going to focus on this voltage, 230 volts, because if I bought a light bulb, it doesn't tell me the current that it prefers. It tells me the power. So let's get some pictures of some different appliances. This is a 14.5 watt light bulb. Now, in the past, you used to have, these are energy saving light bulbs. Now, pretty much all light bulbs nowadays are energy saving. We don't call them energy saving anymore, probably, I suppose. We just call them light bulbs. But in the past, you would have to use a lot more power to get the same amount of brightness. So if we refer back to our energy lesson, you could imagine how the Sankey diagram might look a bit different. You'd have a greater efficiency, less energy wasted. But we won't go into that at this point. We're saying that we're going to just say that the power for this light bulb, is equal to 14.5 watts. How are we going to use this to calculate the current? Well, it would depend on the voltage, because the electrical power is also calculated by current times voltage. So the current would be equal to the power divided by the voltage. And we know what the voltage is because it's 230 volts. And we know what the power is in this case. So it's 14.5 divided by 230. Okay. So you can see, well, what's going to be the value for that then? So the current for that is really, really quite small. So you're not going to need a very high fuse at all, right? So you can, but basically the larger the power of the thing that you're using, the higher the fuse that you're going to need to use. Okay, so maybe we can do some questions on how to decide what fuse to use.